I am Anil Kumar. Welcome to my series on trigonometric equations. For test preparation, we have 4 questions here. I'd like you to pause the video, copy the questions, solve them, and then look into my suggestions. Solve the following equations in the given domain. Question 1. 3 sine square theta plus sine theta equals to 0, where theta is between 0 to 360 degrees. Question 2. 2 sine theta minus tan theta equals to 0. Provide general solution. Question number 3. 4 sine square theta minus 5 cos theta equals to 5, where theta is between minus 180 degrees to 180 degrees. Question number 4 is 4 sine theta cos theta minus cos square theta plus 4 sine theta equals to cos theta. Theta is between 0 to 360 degrees. You can always pause the video, answer the questions, and then look into my suggestions. Now let's begin with the very first one, which is 3 sine square theta plus sine theta is equal to 0. To solve this, we should actually factor, correct? So let me copy the question first. We have 3 sine square theta plus sine theta equals to 0. So you can take sine theta common. So we get 3 sine theta plus 1 equals to 0. So now we have two factors. We can equate sine theta to 0 and we can equate 3 sine theta plus 1 to 0. Sine theta equals to 0 and the domain given to us is from 0 to 360. We have 3 solutions in this domain for sine theta equals to 0. The best way is, of course, to look into the sine graph itself in this particular domain. That is the sine graph, and the 3 solutions are right there. We can write down our solutions. We say theta equals to 0 degrees, 180 degrees, and 360 degrees. Correct? So those are the 3 values. Now for the second equation, we'll get 0 if sine theta equals to minus 1 over 3. Now that means we're looking for solutions in quadrant 3 and 4, right? So these are the quadrants of our interest. How did we get that? Well, the cast rule. Sine is negative in quadrant 3 and 4. So what are we going to do? We'll find the reference angle. Let's find the reference angle alpha and then solve it. So let's do it on the right side of this page. So we have sine theta equals to minus 1 over 3. We are saying let sine alpha, the acute angle, be, it is going to be always positive, right? So in that case, alpha will be equals to sine inverse of 1 over 3. Use the calculator to find the answer. Shift sine inverse of 1 divided by 3 is equal to 19.47. Let me round this and write this as 19.5 degrees. So we got the acute angle. Now, the solution actually is these two principal angles, correct? These are your solutions. So the angle theta within the domain of 0 to 360 degrees will be what? Will be 180 degrees plus 19.5 and 360 degrees minus 19.5 degrees, correct? So those are the two solutions for the second factor. So let's find the answer value here. So when you add 19 to 180, you get 199.5 degrees. And when you take away, you can take away 20 from here first and then add 0.5, right? So when you take away 20, you get 340.5 degrees, correct? So that is how we could get the angles. And now, as far as the solution is concerned, we'll add to the list of 3 these two also, so which is 199.5 degrees and 340.5 degrees. So our solution set is these five values. Is that correct? That is how we could solve the very first question. Now let's move on and take the next question. The question here is 2 sine theta minus tan theta equals to 0. We need to provide general solution in this particular case. Now, tan theta can be written as sine over cosine. So let's rewrite this as sine theta minus sine theta over cosine theta equals to 0. So we can take sine theta common. So we get 2 minus 1 over cos theta equals to 0. So for that to be true, we have solutions for sine theta equals to 0, and we can say 2 is equal to 1 over cos theta. Now sine theta equals to 0, as we saw last time, we can say theta is equal to, we have to provide general solution, right? So let us see how to write the general solution, and then I'll write down the answer here. So let me explain you that part. So okay, let's explain here itself. I'll write solution there. So a sine wave can be drawn like this. So that means that for every interval of 180 degrees, it is going to be 0, starting with 0, right? So generally, we can say theta equals to 180n. So we could write the general solution as theta equals to 180 degrees times n, where n belongs to integers. Does make sense to you? It becomes a general solution. You can give value of n as 0, 1, 2, 3, 4, or even negative 1, negative 2, negative 3, and so on. What you get are these points where we have zeros for sine theta. Correct? So that becomes one part of the solution. Now let's look into the other part, which is cos theta is equal to half. So rearrange this and write down this as cos theta equals to half. Cos theta is positive half. Which quadrant are we looking into? We can apply the cost rule. So cos is positive in quadrant 1 and in quadrant 4. So we expect the solution in these two quadrants. Let's find the acute angle alpha. So we can write this as cos alpha equals to half, which is also one of our solutions. And we say alpha is equal to, well, cos alpha, alpha is 60 degrees, right? You know this special triangle? You can always use this special triangle in such cases. 30, 60, 90, where the angle here, 60 degrees, will give 1 over 2 as the cosine value. So we know this angle alpha is 60 degrees. The other angle is how much? 360 minus 60, correct? So this will be 360 minus 60. So we get the value of theta as 60 degrees and 360 degrees minus 60 degrees, which is 300 degrees. So we have these two solutions. So now we can write down the general solution for this. So what is the other way of looking into it? See, you could also see that we could write 60 and minus 60. Do you see that? So we could say that this theta is plus minus 60 degrees, and it is repeating after every 360 degrees. So we could add 360 n to it. Do you get the idea? So now let me summarize to write the answers. The general solutions as 180n, and we have plus minus 60 degrees. It could be positive or negative, plus 360n, where n belongs to set of integers. Correct? So that should be the general solution for the given equation. I hope it makes sense. Now let's take question number 3. Question number 3 here is 4 sine square theta minus 5 cos theta equals to 5, and we have to work in the domain minus 182 plus 180. It's not 0 to 360. So look at the domain to provide answers. Now this is a quadratic equation. Let's write down this quadratic equation in one term. So we could actually convert sine square theta into cos by writing this as 1 minus cos square theta. And here we have minus 5 cos theta. Bring 5 to this side equals to 0. So we get 4 minus 4 cos square theta minus 5 cos theta minus 5 equals to 0. Well, it is a good practice to keep the leading coefficient positive, so we'll actually interchange it later. Let's combine these two terms and write this as minus 4 cos square theta minus 5 cos theta minus 1 equals to 0. We will also write this as 4 cos square theta plus 5 cos theta plus 1 equals to 0. So that gives you the form which we need to factor. So we have here, let me check the questions, because we have 4 times 1, which is 5, and we need 5 cos theta, which we cannot get. So what we need to do here is we need to find what cos theta could be using quadratic formula. So cos theta could be equals to minus 5 plus minus b square, which is 5 square minus 4ac. That means 4 times 4 divided by 2 times 4. So that becomes the quadratic formula, and let's find what this value is. So that gives us cos theta equals to minus 5 plus minus square root 5 square minus 16, 25 minus 16, right? Over 8. And that is minus 5 plus minus. So let's use the calculator to find this answer. Square root of 25 minus 16 is 3. So that is 9. Yeah, plus minus 3 over 8. So that gives you minus 8 over 8, which is minus 1. And we also have, when we have plus 3 here, so we have minus 2 over 8, which is minus 1 over 4. So those are the two possible solutions, correct? So that means we have to work for cos theta equals to minus 1 and cos theta equals to minus 1 over 4. So for cos theta equals to minus 1, within this particular domain, what is the solution? Well, cos theta is minus 1 for 270 degrees, right? So let's look into the cosine graph once. Cosine graph can be sketched as, let me sketch it here. Okay, so it is minus 1 at these points, correct? Those are the points where it is negative 1. So at 180 degrees plus and minus, it is minus 1. Since both are included, we can say theta is equals to plus minus 180 degrees. That is one set of solution. For the other one, which is cos inverse of minus 1 over 4, minus means we are in which quadrant? It is quadrant 3 and 2, right? So in this particular case, cos is negative. Let's apply the cos rule once again. And we know that the solution lies in these two quadrants, negative value. So we'll find theta, rather the acute angle alpha here. So we can say alpha equals to cos inverse of 1 over 4. So let's find this answer now. So shift cos inverse of 1 divided by 4 is equal to 0.999. Let's do it once again. So shift cos inverse of 1 divided by 4. Yeah, that was a wrong answer. This is 75.5. So we get this 75.5 degrees as our answer, right? Now, we're looking for two solutions, one in quadrant 3 and another one in quadrant 4. So the values are, so we could go like this, that is less than 180 degrees, and we could also go like this. So the solution is 180 degrees minus 75.5, correct? That is one. Going from the positive side, since we want plus and minus. The other one is, you can go from the right side, so it is again but negative, right? So it is plus and minus of this. So let's do this. We have 180 minus 75.5, which is 104.5. So we get plus minus 104.5 degrees as our answer. So those are the solutions for us. Let me write down the complete answer now. So our answer in this particular case is, we have minus 180 degrees, we have plus 180 degrees, and we have plus and minus 104.5 degrees. Is that clear to you? Correct? So in this particular case, we use the quadratic formula to factor. And we got our factors as the cosine value equal to minus 1 and minus 1 over 4, which gave us 2, that means 4 values in all. Correct? So those were those 4 values. So that is how we are going to do it. Now, let's take the last question, which is question number 4 for us. Question here is 4 sine theta cos theta minus cos square theta plus 4 sine theta. It's a good practice to bring all the terms together. So I'm keeping this on the left side, bringing it with minus cosine theta equals to 0. Well, the domain is from 0 to 360 degrees, which is the default domain most of the time. Now, how can we do it? Well, we could group factor it. We can take cos theta common here, and we get the 4 sine theta terms common. So we could write this as cos theta is common in the first two terms. We get 4 sine theta minus cos theta. Plus, here we already have 4 sine theta minus cos theta equals to 0. So we can take 4 sine theta minus cos theta as a common term. And we get cos theta plus 1 equals to 0. So here again, the solution could be 4 sine theta equals to cos theta, which actually says that sine theta over cos theta, which is tan theta, I'm writing in one line, equals to 1 over 4, correct? On the other hand, we have cos theta equals to minus 1. So those are the two values. For cos theta equals to minus 1, we know theta is what? We just did it, minus 180 degrees. Correct? So theta is minus 180 degrees for cos theta equals to minus 1. Again, that's the graph for us. Cos theta starts with maximum, right? Ends up there. So the midway is the negative 1 value, which is right there. Now, for tan theta equals to 1 over 4, we might use the calculator. So we'll find the related acute angle and then the solution. So let's do it here. So we're now looking into tan theta equals to 1 by 4, which is positive. That means we're looking into quadrant 1 and quadrant 3. So we'll call this as angle alpha. So we know tan alpha equals to 1 over 4. So alpha equals to tan inverse of 1 over 4. Let's use the calculator to find the answer. Shift tan inverse 1 divided by 4 is equal to 14 degrees. So we get this angle as 14 degrees. So the angle for theta should be 14 degrees and 14 plus 180. So those are the two answers for us. Correct? So when you add 180 to 14, you get 194. So we get the theta value to 14 degrees and 194 degrees. So now combining the results, we have the final answer. So our answer now here is theta is equal to this is 180 degrees because we are in the domain of 0 to 360 degrees. So it is 180 degrees, and here we get 14 degrees and 194 degrees. Is that correct? So that is how we are going to answer this, and it falls within the given domain. Perfect. So that is how you should be solving. So we had 4 questions to begin with. We applied different strategies. Main of the strategy here applied was factoring. So in this particular test, we practiced factoring. We also applied quadratic formula. Correct? And the cast rule. To find all the answers, we worked with the reference angle. We also saw how could we write answer of a quadratic equation in general form. So it is very important to understand all these things to be well prepared for your own test. I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.